Let's see how to implement priority based interrupt driven IO, in which we are going to have more than one device and we have to assign the priorities. And let's see how to implement it in hardware. So there are two ways we can implement it in hardware. One is called as serial connection and other one is called as parallel connection. Let's now look at the serial way of implementing it. It is also called as daisy chain. Okay, so let's see this one, daisy chaining. Daisy chaining. So assume that we have a CPU and it is going to have a lot of pins, but we are mainly interested now in implementing the interrupts. So I'll show you only the two pins. So one is interrupt pin and the other one is interrupt acknowledgement pin. So what happens is, whenever a device raises the interrupt, it is supposed to show the interrupt through this pin. Okay, and whenever we get an interrupt, if the CPU is executing an instruction, it has to finish its instruction execution completely, and after finishing the execution it should enter into the instruction, that interrupt cycle. And whenever it enters into the interrupt cycle, it has to tell that particular device to stop generating this interrupt signal, or it should say that yes, I am processing you. That is how interrupt acknowledgement is being done. Right, so acknowledgement is simple. In other terms, we have already seen acknowledgement, right? We send as a source, we send something to destination, and then we wait for the acknowledgement from the destination to know whether the data has been received by the destination or not. Similarly, here the source of the interrupt is the IO device, and after generating the interrupt, IO device will expect an acknowledgement to come back to it so that it can stop the interrupt, right? And now we are talking about the serial connection. It means many IO devices are all connected to the same serial channel, right? So assume that we have various devices. So instead of using the names, I'll just use the number. Say it is IO device 1. Say this is IO device 2. Say this is IO device 3. So on. We have many devices like that, and how many IO devices we have? We are connecting it to the same serial channel. Now, even if one of them raises the interrupt, they are supposed to put a signal here, and so the CPU will definitely receive interrupt signal. So this particular point will receive an interrupt when even one of the devices raises an interrupt. Therefore, it is like we need not have interrupt from all the devices. Even if one of them raises an interrupt, you are going to see it there. Okay, and now the way we connect this interrupt acknowledgement is the way we are implementing this priority. See this. Now interrupt acknowledgement is first given to IO device 1, and it is then given to IO device 2, then IO device 3, so on. If you have more devices, we are going to give it like that. Now what is the advantage of using this type of connection is, see this. Assume that IO device 1, 2, 3, all of them have raised the interrupt. Then we are going to see the interrupt here. Now we are sending the acknowledgement and we don't know which device has actually raised the interrupt. Then we are sending the acknowledgement to IO device 1. In case if IO device 1 is the actual device which has raised the interrupt, then that particular device will take up the signal and it will not give any signal here, right? Which means the device which is present at the beginning is going to see the acknowledgement first, and if it is the one which requires a service, it will eat up the acknowledgement. Therefore it is going to be service first. In case if IO device 1 is not the device which has raised the signal or which has raised the interrupt, then it will let the interrupt signal pass through it, and that interrupt acknowledgement, I am talking about interrupt acknowledgement, pass through it, and that interrupt acknowledgement will be given to 1. So if you want to understand it, see it this way. So assume that all the three devices have raised the interrupt, therefore you got the interrupt there. Then we are going to send the interrupt acknowledgement. Now interrupt acknowledgement is here. In this case, IO device 1 has actually raised an acknowledgement. It doesn't care whether IO device 2 and 3 they have raised the acknowledgements or not, right? It has raised it. Therefore, it will consume this one and it will send 0 here, and it will send, anyway this is going to send 0 only because it got 0, right? So by seeing this, you can clearly understand that IO1 has accepted the acknowledgement, therefore it is going to be processed now. How is it processed? We shall get into the details slowly, right? In case if this is not the one, if interrupt is actually raised by 1, 2 and 3, then we are going to get the acknowledgement. First acknowledgement will be given to IO device 1. So 1 is given to IO device 1, and now that particular one will be allowed to pass through IO1 because it doesn't want the service, because it didn't raise any interrupt. In this case, this one is going to get 1, but it will send out 0 only. Got it? So in case if these two are the IO devices which have raised the interrupt, then IO2 will get the service first. Got it? So in case if this one also didn't raise the acknowledgement request, then who will get the service? 1. How? This particular signal, acknowledgement signal, will pass through this. Why? This device will allow it because it doesn't need it, and similarly this particular device will also allow the acknowledgement to pass through it and reach the IO device 3. Got it? So if you look at the way we have arranged this, it is very clear that based on the placement of the IO devices, based on the order in which it is placed, we can say that the priority is decided. So IO1 has higher priority, this device has higher priority, this one has second highest priority, this one has third highest priority, and the further the device, the least priority it gets, lower the priority it will get, right? So now what can we understand from this? We are not actually using software polling, we are simply using the hardware devices only. So it is very fast compared to running that default interrupt service routine and then polling and then asking each device. Asking each device means reading the status, right? So that is actually going to take a lot of time, software method. But if you see the hardware method, so whoever raises, we are going to get the interrupt, and whoever catches the interrupt acknowledgement, that is the one which is going to get serviced, right? And I told you that this particular daisy chaining actually falls under the category of vectored interrupt, right? So what is vectored interrupt? The device which needs this service, the device which has raised the interrupt and which needs this service is also supposed to provide the CPU with the address of the interrupt service routine, right? So in the memory there will be separate interrupt service routines for each device, right? Let us say this is device 1, device 2, device 3. Its starting address is 100, its starting address is 200, starting address is 300. Every device has its own starting address in the interrupt service routine, right? Therefore it is the responsibility of the device to provide the address as well. So for that reason there will be a bus. Generally we will use the data bus itself. So all the IO devices are also connected to a bus, either the IO bus or the common bus or the data bus, whatever it is, there has to be a bus, right? And now we are going to connect the IO devices to this bus, and depending on which one caught the acknowledgement, that particular device is supposed to transfer its address, right? So generally that is also called as vector address, right? Vector address means that is a shortcut to say that this is the address at which the service the interrupt service routine for this particular device is residing. Got it? So every device has to supply the address. Now let's consider a scenario. All the three devices have generated an interrupt, and interrupt acknowledgement is being sent. Then that will be caught by IO1 and it will send 0 here. So since the input is 0, output of this one will be 0. That is how it is made, and output of this one is also going to be 0. So it is clear that IO device 1 has now got the acknowledgement, which means IO device 1 will understand that it is going to be serviced next. So based on that understanding, it will put the vector address which it knows onto the bus. Now this particular address will be loaded into the CPU, and CPU will branch to that particular address, and then it will start executing. Got it? So it is completely a hardware based implementation. So even though it is completely hardware based implementation, ultimately the interrupt service routine has to be a software. Therefore software is also there, but still most of the things are done in the hardware level. And as you know, whenever we do things in hardware, they will be much faster compared to software implementation, because for software implementation we have to fetch an instruction, check it, and there has to be a lot of things done, a lot of instructions have to be executed. But here without that, in few cycles we can get what we need, right? And we'll get down to the problem and try to address it, right? So this is the way we have addressed the problem using the serial connection. Now let's try to address the problem using the parallel connection. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries, for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.